Welcome to this video on the graphs of sine, cosine and tangent, which we're going to discuss in a few moments. There are the graphs, okay? That's sine, that's cosine, and this one here is tangent. And you'll notice that the sine and cosine have a couple of things in common. That is that they have a maximum value of 1 and a minimum value of -1. Okay, they also both repeat themselves every 360 degrees. Okay, the difference is that one of them, the cosine graph, is 90 degrees out of synchronization with the other. Okay, in fact the cosine graph is the same as the sine graph but translated 90 degrees to the left. Okay, now the tan graph is different. Okay, what appears to be happening here is it's going off from 0 off towards infinity before it gets to 90 degrees. Then it's coming in from negative infinity, going back through 0 at 180 degrees. And we're going to look at that in more detail in a moment. The other thing to note is that it repeats itself every 180 degrees. Okay, now look at this animation. Here we have a circle on the left with a radius of 1 unit. And as it plots out a path from 0 degrees now round to 360 degrees, it shows on the graph how high above the 0 line that point on the circle is. So here it's going from 0 up to a height of 1, back down to 0 at 180 degrees, to -1 at 270 degrees, and then back to 0 again at 360. And it just keeps repeating that every 360 degrees. All right, the cosine graph would be traced out in a similar way, except instead of looking at the vertical height of the point, it would be looking at its horizontal distance from the center of the circle. Okay, back to the graphs, and we're now going to explain why the graphs form the shapes that they do by considering the basic definitions of what sine, cos and tan mean in the context of a right-angled triangle. So here we are. Here's a typical right-angled triangle. We have an unknown angle theta. We have an opposite, an adjacent, and a hypotenuse. Okay, what is always true is that the hypotenuse is the longest side. That means it's always greater than the opposite, and it's always greater than the adjacent. So if we consider the meaning of sine and cos and the definition, we know that the sine of an angle is a fraction where the opposite is over the hypotenuse, and the cos is also over the hypotenuse. And because the hypotenuse is the largest side, it means the adjacent and the opposite are always less than the hypotenuse. In other words, in these fractions, the numerator is always less than the denominator. Therefore, they're both less than 1 whole 1 or greater than -1. Okay, now in the case of the tangent, anything goes because the opposite and the adjacent can be any size relative to each other. So for example, in this top triangle here, we can see that the opposite is many times smaller than the adjacent. So the tangent of this angle here in this example might be about 1/10. And if theta got smaller, it might become 1/20 or 1/30. So a small fraction close to 0. However, in this one, where theta's getting close to 90 degrees, so maybe that's about 85 degrees, you can now see the opposite is many times bigger than the adjacent. So maybe the tangent is about 10/1, okay, and if the hypotenuse, if that angle increased more to maybe 89 degrees, the opposite could be 50 times more than the adjacent, so the tangent would be 50. Theoretically, if this angle reached 90 degrees, the hypotenuse would be vertical and it would never reach the opposite at all, hence the opposite would go off to infinity, which is why we get those breaks in the tangent graph every 180 degrees. So we'll go back to those graphs now, and there you can see the tangent graph going off to infinity, not reaching this 90-degree mark, then coming back here from negative infinity and going through there. So the next thing we need to look at is how we use these graphs to help us answer questions about angles that might be asked for in an exam question. Let me explain what I mean. Suppose we were looking for an angle that has a sine of 0.5. Now you may know that this is 30 degrees. If you put inverse sine of 0.5 on the calculator, it would give you 30 degrees. But it would also not tell you any other angles that had a sine of 30 degrees. So we can find that out by using our graph. So this is 0.5, and if I put sine to the minus 1 of 0.5, it will give me 30 degrees on the calculator. Okay, and we call that the primary or principal value. Okay, it's the one closest to 0 that has a sine of 30 degrees. But what about this angle then? This also has a sine of 0.5. Okay, so what is it? Well, we use some symmetry here. If I put a line down here, you can see that that's like a line of symmetry. And this distance here is the same as this distance back from 180. So if that first angle there was 30, okay, it means that the other one I've marked is 180 minus 30, which of course is exactly 150. And that seems to be what it shows on the graph there. Okay, so that's quite an easy example. And there will be other angles beyond 360 where this line crosses again, and we wouldn't be interested in any outside the range 0 to 360. Okay, now let's take a negative sine. Suppose we were told that an angle has a sine of negative, let's say 0.6. So I'm just going to mark that on here now. Negative 0.6. It's about there. Okay, so if I took my line across from negative 0.6, okay, it's showing two angles, there and there. Okay, but what are those angles? Well, if I go to the calculator and put in the inverse sine of negative 0.6, it gives me negative 36.9 degrees. Okay, so I've just put into the calculator shift sine, or sine to the minus 1 of negative 0.6. Okay, and it's given me negative 36.9. Okay, now that doesn't appear in the range 0 to 360. So how do I know what these angles are? Well, I use the fact that the sine graph repeats every 360 degrees. So if I just add 360 onto that, or in other words do 360 minus 36.9, or minus 36.9 plus 360, it will give me that first angle there that I've shown with the arrow, that one there. Okay, so if I add 360 to that, it gives me 323.1. And if you look at that, that seems about right. Okay, 323.1 degrees. Okay, now the other angle here, that can also be found by recognizing some symmetry. And if I put a line of symmetry down through here at 270, okay, you should be able to see that that distance in from the 360 is the same as this distance added on to 180. Okay, so to find that point there, I need to do 180 plus 36.9. Okay, 180 plus 36.9. Okay, and that gives me 216.9 degrees to 1 decimal place. Okay, so we're finding angles in the range 0 to 360 that have a negative sign. We can do the same kind of thing with cosine, but the symmetry works in a different way. Let's suppose we had 0.7. Okay, let's suppose we wanted to know what angles had a cosine of 0.7. Okay, so that's supposed to be at 0.7 roughly. Okay, let's just put 0.7 there. And according to the calculator, if I put the inverse cosine of 0.7, that gives me 45.6 degrees. Okay, 45.6 degrees. So I have just put in cos to the minus 1, inverse cos in other words, of 0.7, and it's given me 45.6 to the nearest 1 dp. Okay, so that's what this angle here is. Okay, and you can see that from the graph, 45.6. But what about the other one over the other side? What's this one over here? Well, this comes from symmetry, but different symmetry to what we used in sine. Okay, if I put a line through here at 180, you can see now, hopefully, that this distance here is exactly the same as this distance here. Okay, so those two bits of yellow line segment are the same length. So in other words, if I took 45.6 away from 360, okay, that will give me the other angle that I want. Okay, and that there is 360. Okay, I'll write it here, 360 minus 45.6. Okay, and that comes to 314.4 degrees, 314.4 to 1 decimal place. Okay, and that's the angle there. And you could do the same sort of thing with negative angles. Okay, and you could use the fact that the cosine graph repeats every 360 degrees as well as the sine graph, and do what we did earlier here. Okay, and tangent is easier perhaps than the other two, because that simply repeats every 180 degrees. So for example, if I had an angle that had a tangent of, let's say, 1.5. Let's draw that in. So this line here is at 1.5, okay? So I can see there are two places where the graph crosses. So this is 1.5 here, okay? And to find the two crossing places, I put in here shift tan 1.5 in the calculator, and it tells me that this first angle here is 56.3, and that seems about right from the graph. Okay, 56.3 degrees, and that's this angle given here. And then to get the next one over here, all I need to do is just add 180 onto that 56.3, which is 236.3. Okay, so I've just simply added 180 to shift it along. Okay, so that's quite easy to use with the tan graph, and if I added another 180 to that, it would take me to another crossing point that's off this graph. But for GCSE, you're only interested in angles between 0 and 360. Now, if we had a negative value of tan theta, we would have, let's say, -2. So the tan of an angle was -2. So we would be looking at this line across here. Okay, so I'll just draw that in first. So this is -2. And we can see again there are two angles in the range that we're interested in, here and here. And when we go to the calculator and put shift tan -2, the calculator will give us a negative angle. It gives us negative 63.4. So I'm just going to make a note of that here. So tan to the -1, okay, so tan to the -1 of -2 will give me negative 63.4. Okay, now it will always give you the angle that's closest to 0 that has a tangent of whatever number you put in. So negative 63.4 is the closest one to 0, but it's no good to us because it's off the range. But all we have to do is just add 180 to that, okay? And if we add 180 to that, that gives me 116.6, which will be this one here. Okay, so the first one comes from, I'll just make a note of how I got it, 180 plus, or, well, if you like, adding that negative number on, but I'll do it like that. So it's, you're adding on negative 63.4, okay, and that gives you 116.6. Okay, so that one there is 116.6 degrees, okay, to one decimal place. And all you need to do to get the other angle over here is just add another 180 onto that. So I take my 116.6, add 180 onto it, and that will give me 296.6 degrees. And you can see from the graph that seems about right. It seems to fit with what the graph scale is showing us. Okay, so there is there are plenty of examples there of using the sine, cos and tan graphs to find the complete solution set, as we sometimes call it. In other words, all the values between 0 and 360 degrees. Okay, hope that was helpful. Take care.